The medical industry has developed several types of technological devices used to create images of the inside of a human body. These medical imaging systems aid physicians and researchers in detecting, diagnosing, and studying biological conditions, and work by applying energy to the body in order to display detailed pictures of internal structure on film or on the computer screen. The energy emitted by this system defines the type of device being used. There are three types: imaging devices, which use energy in the form of electromagnetic radiation, devices which use magnetic fields, and those which use sound waves. X-rays are the most common type of electromagnetic radiation. They are used to produce images of skeletal structure. X-rays penetrate the body and are absorbed by radiopaque tissues of the body. Bone is an example of a radiopaque tissue, meaning that it does not allow radiation to pass through. Thus, using X-ray sensitive film, doctor can create a Since bones absorb X-rays, they appear as white objects against a darker background, in much the same way that light acute objects produce white forms on the negative film inside the camera. Because X-rays display the detailed image of bones inside the body, they are particularly useful for examining fractures, breaks, and dislocations. They are also used to spot cancerous tumors, respiratory disease such as tuberculosis or black lung, and other abnormalities in bodily tissues. Because X-rays create a two-dimensional image, however, they capture only a slice of the body's three-dimensional structure. As a result, tissues of similar densities are sometimes indistinguishable on an X-ray image. X-rays are also potentially harmful to patients. High doses of radiation can damage human tissues and cause reproductive defects. CT is still widely used today. It is gradually being replaced, however, by magnetic resonance imaging, or MRI. MRI uses a strong magnetic field and radio signal instead of dangerous X-rays to produce images of body parts. When placed in the magnetic field, atoms in the body respond to radio signals by emitting electromagnetic signals of their own. These signals are then collected through sensors and analyzed on the computer to create a three-dimensional image of internal structures of the body. MRI differs from CT in that it distinguishes tissues based on the type of atoms they contain rather than their relative densities. CT is still widely used today. It is gradually being replaced, however, by magnetic resonance imaging, or MRI. MRI uses a strong magnetic field and radio signal instead of dangerous X-rays to produce images of body parts. When placed in the magnetic field, Atoms in the body respond to radio signals by emitting electromagnetic signals of their own. These signals are then collected through sensors and analyzed on the computer to create a three-dimensional image of internal structures of the body. MRI differs from CT in that it distinguishes tissues based on the type of atoms they contain rather than their relative densities. While CT and MRI are extremely valuable in detecting structural conditions and abnormalities, they are poor indicator of chemical and electrical processes in the brain and body. Positron emission tomography, or PET, offers this capability. In PET, patients ingest or are injected with a mildly radioactive substance that can be monitored as it moves through the body. Functional magnetic resonance imaging, or fMRI, uses a magnetic field like that used in an MRI to create similar images of metabolic processes. Another imaging technique is ultrasound, which produces an image by bouncing sound waves of an object inside the body. A picture is then made using the reflected sound waves. The frequency of sound waves used in ultrasound imaging ranges above human hearing. The choice of frequency depends on how deep into the body the sound waves are needed to penetrate. Lower frequencies allow doctors to see structures deeper inside the body. The lower the frequency, however, the less clear the image will appear. Doctors use ultrasound to visualize the size and structure of internal organs, such as muscles and tendons. An ultrasonic image will also reveal unwanted lesions or internal growth. In addition, ultrasound is often used to view the development of a fetus inside a mother's womb.